Hello there, and then welcome back to a brand new video. Now, in our first video, we mastered how to simplify sets. In this lesson, we are putting that skill into use by learning how to add and subtract sets. Now, this is actually very simple, as you would see. It is just like how we group like terms in algebra. So without much ado, let's quickly look into it. Now, there are just two rules that govern addition and then subtraction of sets. Okay, the rules say that, or they state that you can only add or subtract two sets if they are like sets. And like set here, we mean they should either be of the same radicand and also of the same index. In our first lesson, we learned what the radicand is. So if you want to add or subtract two sets, the same radicand here simply means that if it is the square root of 2, you can only add it to another which is of the square root of 2. You see, so we have square root of 2 here, and then we have square root of 2 here. That means we can add them. So generally, we can then say that we can only add and subtract a plus or minus b root a. You see, it is possible if only our radicands are the same. That is what the first is talking about. Now, the second rule, we can only add and subtract if the index are the same. What it means is, if you have the square root of a and you want to add or subtract it to the cube root of a, even though the first rule satisfies, that is, the radicands are the same, the index are not the same. This here has an index of 2, this has that of 3. Hence, we cannot add or subtract. We can only do that if and only if the index are the same. This is the theory of it. So let's take some practical questions and then see how best we can apply these two rules. So we have our first question here, which says we have to simplify the said 2 root 5 plus 5 root 5. So our solution. Now, as you can see here, both terms already have the same radicand. That is 2 root 5 plus 5 root 5. So since they all have the same radicand, what we actually do is we just add the coefficients. You see, so we have 2 plus 5 in a bracket, then root 5. Let me just set an analogy here. So we have 2 root 5 plus 5 root 5. It is the same as 2x plus 5x. What would you have done in this case? You just add the 2 to the 5. That is 2 plus 5. Then your x is still as it is, giving you 7x. You see? So it is this same idea we try to apply here. 2 plus 5 in this case gives us a 7. So you write as 7, then root 5. As simple as that. You see? So you see how easy adding and then subtracting sets are. Let's take some few more examples. If we take a look at this over here as well, it is also very straightforward. So you can even pause and then let me know the answer in the comment section. We have 8 root 10 minus 3 root 10, then plus 2 root 10. What do we do? Since the said expressions are all the same, we just add the coefficients. Or since there's a subtraction, we do that. So we have 8 minus 3 plus 2. Where are we getting this from? The coefficient over here. You see, so 8 minus 3 plus 2. And then the root of 10 comes as you see. 8 minus 3 gives us a 5. Then a 5 plus 2 gives us 7. So this gives us 7 root 10. Now there are instances where the said expressions aren't just as these, as you see over here. Let's take some examples that we are going to apply those. Then we see how that is going to be. So for this example here, we have to simplify the said root 8 plus root 18. Now, you might say, well, since our radicands aren't the same, then we can't do anything about it. But before you make such conclusions, you try first of all and ask yourself. So we need to try as much as possible to see if we can simplify them. If we simplify and there is still no common terms or like terms, then we can say that is just our final answer. Looking at these two, 8 and then what do you call it, 18. Our 8 here, if we want to simplify, we ask ourselves, just as we did in the first lesson, is there a way we can rewrite it as a factor or as a multiplication of a perfect square and then another number? Yes. So our 8 can actually be written as the square root of 4 times 2. You see, so you have the square root of 4 times 2 because we know 8 is equal to what? 4 times 2. Then plus the square root of 18 here can be written as what? So you have 9 times 2. So what we are trying to do is we want to simplify them because these are not the simplest form you can write these said expressions. You see, unlike the previous examples we did, these over here, the 10 had no factor that is a perfect root or a perfect square. So it was already in its simplest form. But these, on the other hand, do have factors that are perfect squares. So with this now, what we do is we want to simplify. And since we've already done simplification, I'll just go straight for it. And we say we have square root of 4 times square root of 2. Then plus the square root of 9 times the square root of 2. And we know the square root of 4 gives us a 2. So we have 2 times root 2 plus the square root of 9 gives us 3. So times root 2. Simplifying further, we have 2 root 2 plus 3 root 3. And this here now is in a form we can work with. So it's actually root 2 and not 3. So root 2. So 2 root 2 plus 3 root 2. And this here now is in a form we can easily work with because the said or the radicands are the same. So because first of all the radicands are the same, and then we are having the same index, that is root 2, square root, and then square root. So let's go on and then solve to see what we are going to get. With this being our question, we are going to say 2 plus 3, that is adding the coefficient, then root 2. And 2 plus 3 gives us a 5. So we have a 5 root 2 as the solution to what? Root 8 plus root 18. That gives us what? 5 root 2. Very, very simple. Now let's take this last example here and then see how it's going to go. We have 4 square root of 27 minus square root of 75. So the first thing you need to do is to take your root 27 and evaluate it. You see, and by now I do hope you can do all those evaluations. So you have 4, and then the square root of 27 will actually give us 3 root 3. Then minus the square root of 27. If evaluated, we have 5 root 3. How did I get it? 27 is actually 9 times 3. And the square root of the 9 is the 3. So the 3 comes here. Then the root 3. 75 is 25 times 3. Square root of 25 gives me my 5. Right? These are all things we have done already in our first lesson. So We now come and multiply this 4 by the 3 here. So that we have 4 times 3, because this is a coefficient, it is multiplying everything. Okay, so 4 times 3, just as you'd have said 4 into bracket 3x. So that 4 times 3 gives us the 12x, right? That's the same idea we want to apply here. So 4 times 3 gives us 12, then root 3 minus your 5 root 3. You now work only on your coefficients. So 12 minus 5 in one bracket, then root 3. And 12 minus 5 gives us a 7. So we have 7 root 3. This here now is your final answer. In simple terms, we can only add and subtract sets if they have the same radicand and the same index. If not, then you just leave them as they are without solving, right? I do hope these few examples we have done is enough for you to solve these exercises I'm about to give. So these are the questions. There are 5. You have to simplify them using what we've learned so far. So for the very first one, the sets are all the same. That is, the radicands are the same. These are not. So you look for how or a way to make them look the same. These are also not. And these are also not. With these 3 here, you should have an idea of changing this also to 3 and changing this as well to 3. With this 11, that should also give you an idea to change this to what? 4 times 11. I do hope this lesson was helpful. If there's any issue of concern, you can always let me know in the comment section. I'll address that. Here's how beyond numbers where we learn maths the easy way. See you in our next lesson, and bye for now.